All right, 10.4, inscribed angles and polygons. An inscribed angle is an angle whose vertex lies on a circle and whose sides contain chords of the circle. All right, so what that means is that it's a angle that's in a circle, that its edges on the circle, like its vertex, and then also both of its sides touch the circle, right? So this is talking about that angle right there. We also have some definitions there that you can pause the video and copy down if you'd like. 10.10, measure of an inscribed angle theorem. The measure of the inscribed angle is 1/2 the arc, right? So the measure of this angle is 1/2 of the arc right there. Example 12, we're trying to find that angle there. Well, that's going to be 106 divided by 2, right? Because y is an inscribed angle, which is 53 degrees. Next up, example 13. Find the measure of arc VW, which is this little piece right there. Well, this is a diameter, so it splits the circle in half. This angle is an inscribed angle, right? Even though it's really close there to that edge, there is a little gap there. That is an inscribed angle. So this arc is going to be 75 times 2, which is 150. Arc VW will be half the circle, which is 180, minus 150, which is 30. Next up, measure of arc DA, and we're supposed to find the measure of angle ABD. So ABD is this one here, and then arc DA is this arc. Well, starting off, we can look at this angle. It opens up to that. That's an inscribed angle, so this is going to be 90, right? Because 90 is 45 times 2, so that's what the arc is. And then I divide back by 2 to get angle B, which is going to be 45 degrees. The inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. And I want to scroll back up to the previous example to talk about this one. Let me erase what I have on the circle. We have this angle. It opens up to this arc, which also belongs to this angle. Right? So just like in example 14 where we showed that angle B and angle C are equal, that's what this theorem is saying. Anytime that we have an angle whose endpoints or whose arc is the same as another angle, then it's going to be congruent. So it doesn't matter which angle we have here, as long as it has endpoints that are on arc AD, it's going to be equal to it. Right? As long as its endpoints are on the same arc, then the inscribed angle will be congruent. An inscribed polygon. A polygon is an inscribed polygon when all its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. Right? And there in our picture we have an inscribed polygon and a circumscribed circle. 10.12, the inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Right? And we can say that in reverse. So conversely, if one side of an inscribed triangle is a diameter, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So let's think about this for just a moment in this picture. So this is a right triangle, or here, we'll start thinking about it as this is our diameter, which breaks it up into two half circles. So this is 180 degrees. This angle is an inscribed angle with endpoints on the diameter, So this angle would have to be 180 divided by 2, which is 90. Right. And that's what this theorem is saying, that by using inscribed angle rules, right, how we have to divide by 2 of the arc, we're able to get that 90 degrees. Or we could multiply by 2 and get that 180 degrees. Alrighty. 1013, the inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, right? And supplementary means 180 degrees. So if you see a four-sided figure inside a circle, then its opposite angles are supplementary. They add up to be 180. Example 15, this one is a triangle inscribed in a circle. This is our diameter, which means that this is 180. So this right here is a right angle, right? So we could say, well, 3x is 90, so x is 30 degrees. Next up, this one is a four-sided figure. It's a quadrilateral. It's inscribed in a circle because all of its edges, its endpoints, its vertices here are all on the circle. So I can say, well, y plus its opposite angle, which is 83, is 180. And I can also say that z plus 82 is 180. So y would be, what would y be? 97, and z would be 98. Right? They are not equal, they're supplementary, right? It's a common mistake to say that, well, these guys are opposite, so they have to be equal. That's not true. That is not true. They are supplementary. They add up to be 180. All right, that is 10-4.